GCE O Level Mathematics, Lecture 27, Matrices. Hello everyone, Dennis here. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Let's start the lecture with the learning objectives of this lesson. So, we are going to learn how to display information in matrix form, identify the order of a matrix, interpret data in a given matrix, perform addition, subtraction, scalar multiplication, and multiplication of matrices. And lastly, solve problems involving calculations of the sum and product of two matrices. So let's get started now. First of all, what is a matrix? So a matrix is a rectangular array of numbers arranged in rows and columns. Here's an example. So this is a matrix. From here, the number of rows m is 3. Alright, so let's count. Here, this is 1 row, 2 rows, and 3 rows. So the m is equal to 3. How about the columns? The number of columns n. So this is 1 column, 2 columns, 3 columns, 4 columns. So hence n equals to 4. The order matrix is expressed in the form of m times n, where the m means the number of rows and the n means the number of columns. So for this case, the order of the matrix will be 3 times 4. So here's an example. Can you fill in the blank? A 2 times 3 matrix has how many rows and how many columns? Yes, it has 2 rows and 5 columns. The numbers inside a matrix are called elements of the matrix. Now from this example here, can you state a few elements in this matrix? Okay, you can randomly choose some elements inside here. Can be -3, can be 0, can be 6, and so on. Alright, in general, the elements of a matrix can be labeled as follow. So in a 2 times 2 matrix, it can be written as A11, A12, A21, A22. So this A11, 12, these numbers can tell where is the location of the element. So 11 means first row, first column. The last one, A22, the second row and second column. So similarly, if you have 2 times 3 matrix, which is in this manner, A11, A12, and so on, until the last one is A23. So again, the numbers over here is indicating the location of the element. So let's say this one, A22, means this element is in the second row and second column. Okay, let's put it in the more generic form, m times n matrix. So when label the elements inside the matrix, you will start with A11, A12, and so on, to the last column, A1n. So go to the second row, A21, A22, until the last column, A2n. And continue the same process to the last row, AM1, AM2, and so on, until the last matrix or last element, AMN. So this element is in the m row and nth column. Here are a few special matrices that you should know. The first special matrix that you should know is a row matrix. So a row matrix is a matrix that only has a row. So if we in the order of 1 times n. Remember, the first number tells us the number of rows. So since this is a row matrix, it only has a row. So it will be 1 times n, where it can have multiples of the column. So here are a few examples. The first example, so this matrix, it has 1 row, 2 columns. So the order will be 1 times 2. This example, it has 1 row and 3 columns. Hence the order is 1 times 3. Alright, so the next special matrix that you should know is the column matrix. So what is a column matrix? It is a matrix that only has a column. So it will be in the order of m times n. Again, remember the second number tells us the number of columns. So since this is a column matrix which only has a column, hence it will be always 1 here. So here are a few examples here. The first example. So this example we have 2 rows and 1 column. Hence the order is 2 times 1. Another example here. This matrix it has 3 rows and 1 column. Hence the order will be 3 times 1. Next, another special matrix that you should know is a square matrix. So a square matrix is a matrix that has equal number of rows and columns. So it will be in the order of m times m because both numbers are the same. Here are a few examples here. So this example, it has 2 rows and 2 columns. Hence order is 2 times 2. I will say this is a 2 times 2 matrix. Another example here. So this matrix has 3 rows and 3 columns. Hence it is a 3 times 3 matrix. Next, you should also know what is a null or zero matrix. So a null or zero matrix is a matrix with all its elements are 0. Here are a few examples here. So this is the first example, a matrix of the order 2 times 3. So all elements inside are 0. So another matrix, we have 3 rows, 2 columns, and every element inside this matrix is 0. Next, let's talk about the operations of matrices. So the first operation is the addition and subtraction of matrices. Matrices can be added or subtracted with the condition where they have the same order. Here are a few examples. For A, the first matrix 2, negative 1, 7, 3, plus with the second matrix 1, 5, negative 3, negative 2. So let's check the order for the first matrix. It is 2 times 2. And the order for the second matrix, it is also 2 times 2. So both have the same order. So now we can add them together by adding the corresponding elements. So these 2 plus with 1 here, we have 2 plus 1. Negative 1 plus with 5, we have negative 1 plus 5 here. Then 7 plus negative 3, so 7 plus negative 3. 3 plus negative 2, then we have 3 plus negative 2. After that, we do the calculation. For every element here, we will have 3, 4, 4, 1. And the order for this result will be 2 times 2. So as you can see, all of these 3 matrices have the same order. Let's see one more example here. So this is the first matrix 1, 5 minus with the second matrix 3, negative 2, and 4. So let's check their orders. So the first order is 1 times 2, and the second order is 3 times 1. As you can see here, the orders for both matrices are different. Hence, subtraction cannot be performed here. So in general, when 2 matrices are either plus or minus each other, the first thing we need to do is we need to make sure that both matrices have the same order. So if both matrices have the same order, then we can either plus or minus for these 2 matrices by adding or minusing the corresponding elements. So A11 plus with B11, and the last one A1n plus with the B plus minus with the B1n. Similarly AM1 plus minus with BM1, and this element AMN plus minus with BMN. Alright, so this is how we do the addition and subtraction of matrices. Alright, next, the second operation of matrices is equal matrices. 2 matrices are equal if they have the same order and have the same corresponding elements. So here's an example. Given that matrix A, PQRS, and matrix B, WXYZ. So if these 2 matrices are equal matrices, or matrix A equals to matrix B, then this matrix PQRS is equals to the matrix WXYZ. where P equals to W, so the corresponding element is the same, P equals to W, and Q equals to X, R equals to Y, and S equals to Z. Alright, so let's see one example here. Example 1. Given A equals 2x plus 3, 4 minus 3y, and 24. Matrix B, W minus 6, 8, negative 14, 3z. And matrix A equals to matrix B. Find the values of W, X, Y, and Z. So here's the solution. Since matrix A equals to matrix B, then the elements in the matrix A, 2x plus 3, 4 minus 3y, 24 equals W minus 6, 8, negative 14, 3z. Now we compare element by element. So the 2 equals W minus 6, hence W equals to 8. X plus 3 equals to 8, hence X equals to 5. 4 minus 3y equals negative 14, 3y equals 18, and y equals to 6. And the last corresponding elements, 24 equals to 3z, then z equals to 8. The third operation of matrices that we want to discuss is multiplication of a matrix by a real number. Multiplying a real number k to a matrix will result in each element in the matrix is multiplied by the real number k. So here's an example. K multiplied with the matrix with the element of A, B, C, D, P equals Ka, Kb, Kc, Kd. As you can see here, this real number k is multiplied inside each element of the matrix. One more example here. If k multiplied with matrix with the element of A, B, C, D, E, F, then it is equals to Ka, Kb, Kc, Kd, Ke, and Kf. Alright, so again, this k multiplied inside with every element inside the matrix. Okay, now let's play with some numbers here. So 3 multiplied with matrix 1, negative 2, 6, 4, negative 3, 9. So what will be the answer? Alright, yes, it will be 3, negative 6, 18, 12, negative 9, 27. Alright, because 3 times 1 we get 3, 3 times negative 2 we get negative 6, 3 times 6 we get 18, and so on, right, until we get the whole result here. Okay, it can be a fraction and a negative number multiplied with the matrix here. Okay, so negative half multiplied with the matrix with the element of negative 8, 5, 1.6. Okay, so again, it can multiply one by one in the element, all the elements inside the matrix here. So negative half times negative 8, I will get 4. Negative half times 5, I get negative 5 over 2. Negative half times 1.6, I get negative 0.8. The fourth operations of matrices that we want to discuss here is multiplication of two matrices. Multiplication of two matrices is only possible when the number of columns of the first matrix equals the number of rows of the second matrix. Alright, so what do I mean? If the order of matrix A, P times Q, and the order of matrix B is Q times R, so which means matrix A has P rows and Q columns, and matrix B has Q rows and R columns. So take a look of this number Q here, Q columns of matrix A and Q rows of matrix B. So these two numbers are equal. Then the product of this matrix A and matrix B, which is A times B, is a P times R matrix. Alright, so this P come from this number, P rows of matrix A. So the result will also have P rows. And the R comes from matrix B, so which means the result will have our columns. Okay, so let's take a look of a few examples here. Matrix 2, 3 multiplied with matrix 4, 5. Alright, so is it possible to multiply these two matrices together? Let's check the order. So the order for the first matrix is 1 times 2. Okay, 1 row, 2 columns. The order for the second matrix is 2 times 1 because we have 2 rows, 1 column. Okay, look at the number here, 2 and 2. So they are equal. And 1 and 1. So this will be the order of the product. Okay, so now we can multiply these two matrices together since these two numbers are equal. So how to multiply? Now 2 times 4 plus 3 times 5. So which we get 23. So as you can see, the result is a 1 times 1 matrix. So 1 row, 1 column. Next, let's look at this example. So matrix 4, 5 times 2, 3. Okay, as you can see, the difference between these two examples is we just switch the position for the matrix here. Okay, is it possible to multiply these two together? Now let's check. So this is the order for the first matrix, which is 2 times 1, and the order for the second matrix is 1 times 2. So these two numbers are same, hence we can multiply these two matrices. And 2 and 2 here, which means the result, right, we'll get a matrix of 2 times 2. Okay, now how to multiply? So first 4 multiplied by 2, and the next element 4 times 3, another element 5 times 2, and the last element 5 times 3. Then we calculate everything, we get 8, 12, 10, 15. So this is the order of 2 times 2 matrix. So now compare these two results. Let's say this is matrix A times matrix B, and this is matrix B times matrix A. So we can take note that multiplication of matrices is not commutative, which means matrix A times matrix B is not equals to matrix B times matrix A. Now let's see more examples here. So I have matrix 1, 2, 3, 4 multiplied with matrix 5, 6. Can these two matrices multiply together? Let's check. The order for the first matrix is 2 times 2, and the order for the second matrix is 1 times 2. Take a look at these two numbers. They are not the same. Hence, these two matrices cannot be multiplied together. Alright, now let's see this example. The first matrix is 1, 2, 3, 4, and the second matrix is 5, 6, 7, 8. So the order for the first matrix is 2 times 2, and the order for the second matrix is 2 times 2 as well. So we check these two numbers together. They are the same. Hence, these two matrices can be multiplied together. Alright, so the next question is how can we multiply these two matrices together? So what you can do is, for the first matrix, you group the elements in this manner on a horizontal manner. For the second matrix, you group the elements in vertical manner. So after that, you can start to multiply them together. So the first element of the product will be 1 times 5 plus 2 times 7. The next element for the product will be 1 times 6 plus 2 times 8. The third element of the product will be 3 times 5 plus 4 times 7, and the last element for the product will be 3 times 6 plus 4 times 8. Then we calculate everything together. We have 19, 22, 43, and 50. So this is the product of the matrices with the order of 2 times 2. Alright, now we move on. Let's switch the position of the matrix. Just now we have matrix A times matrix B. Now let's try matrix B times matrix A. So it is 5, 6, 7, 8 multiplied with 1, 2, 3, 4. So again, let's test if we can multiply these two matrices together. The order for the first matrix is 2 times 2, and the order for the second matrix is 2 times 1. So look at these two numbers. They are the same. Hence, these two matrices can be multiplied together. So next, we'll group the first matrix in this manner. So the elements are grouped horizontally, And for the second matrix, we group the elements vertically in this manner. Alright, and now we can start to multiply them together. So the first element for the product will be 5 times 1 plus 6 times 3. The next element of the product will be 5 times 2 plus 6 times 4. Next, the element will be 7 times 1 plus 8 times 3. And the last element for the product will be 7 times 2 plus 8 times 4. Then we calculate everything together. We'll have the result is 23, 34, 31, and 46. And now let's compare the results for these two examples. We can see that multiplication of matrices is not commutative, which means matrix A times matrix B is not equals to matrix B times matrix A. In general, when a P times Q matrix is multiplied with Q times R matrix, so this is how it looks like for the first matrix. The elements are A11, A12, all the way to the last column, A1Q, followed by the second row, A21, A22, all the way to the last column, A2Q, and continue until the last row, AP1, AP2, all the way to the last column, APQ. Multiply with the second matrix, where the elements are B11, B12, all the way to the last column, B1R, followed by the second row, B21, B22, all the way to the last column, B2R, and follow row by row to the last row, BQ1, BQ2, all the way to the last element, which is BQR. So to multiply these two matrices together, the first thing we have to do is, for the first matrix, we will visually group the elements in horizontal manner. For the second matrix, we will visually group the elements in vertical manner. Alright, so the next step, now we can multiply these two matrices together, where the product for the first element will be A11 times B11 plus A12 times with B21 plus all the way to the last term, A1Q times BQ1. Next, we follow the next element, which is A11 B12 plus A12 times B22 plus all the way to the last term, A1Q BQ2. We continue the process until the last column, where it is A11 B1R plus A12 B2R plus all the way to the last term, A1Q BQR. Next, we go to the second row, which will get A21 B11 plus A22 B21 plus all the way to the last term, A2Q BQ1. So we go to the second column, we will get A21 B12 plus A22 B22 plus all the way to the last term, A2Q BQ2. We continue the process until the last column, which we have A21 B1R plus A22 B2R plus all the way to the last term, A2Q BQR. We continue the process row by row until we go to the last row. So the elements will be A P1 B11 plus A P2 B21 plus all the way to the last term, A PQ BQ1. Now the next element will be A P1 B12 plus A P2 B22 plus all the way to the last term, A PQ BQ2. And again continue the process until we go to the last column. We have A P1 B1R plus A P2 B2R plus all the way to the last term, A PQ BQR. So from here, the result will be a P times R matrix. The fourth operation of matrices is square of a matrix. Consider this matrix A, B, C, D. So when you square it, it is not equals to we square each element inside the matrix, but we should multiply the same matrix itself. In this manner, matrix A, B, C, D times with matrix A, B, C, D. And then we use the same method to multiply these two matrices together, which will get A squared plus BC, AB plus BD, AC plus CD, CB plus D squared. Now let's look at this example. If we have a matrix of negative 5, 3, 7, negative 1 square, so it is equals to this matrix multiply itself. Negative 5, 3, 7, negative 1 times with negative 5, 3, 7, negative 1. And now we can start to multiply these two matrices together, which will get negative 5 square plus 3 times 7. The next element, negative 5 times 3 plus 3 times negative 1. The next row, 7 times negative 5 minus 1 times 7. And the last element, 7 times 3 plus negative 1 square. Then we calculate everything, we will get 46, negative 18, negative 42, and 22. Take note that a matrix can only be squared if it has the same number of rows and columns, which is a square matrix. After learning all the operations of matrices, now let's look at more exciting exam-based examples. Example 2. Given matrix A, negative 4, 6, matrix B, 3, 2, matrix C, 5, X, and matrix D, Y, 9. A. Find, number 1, 5A plus 3B. Number 2, half A minus B. B. If phi D equals 2A plus 3C, find the value of X and Y. So here's the solution. For A part 1, 5A plus 3B, all we need to do is just substitute the matrix A and matrix B. So it is equals to 5, matrix negative 4, 6, plus 3, matrix 3, 2. Then we multiply the constant into the matrix. We will have negative 20, 30, plus 9, 6. And add the elements one by one. Negative 20 plus 9 is negative 11, 30 plus 6 is 36. Hence the answer is negative 11, 36. Part 2. Half A minus B. So just substitute again the matrix A and matrix B. We have half, then negative 4, 6, minus matrix 3, 2. So we multiply the half into the matrix A. We have negative 2, 3, then minus 3, 2. And now we minus the elements by element. So negative 2 minus 3, we get negative 5. 3 minus 2, we get 1. Hence the result is matrix negative 5, 1. B. So given the equation 5t equals 2a plus 3c, just substitute the corresponding matrices. We have 5, then matrix y, 9, equals 2 matrix negative 4, 6, plus 3 times matrix 5x. They will multiply the constants inside each elements of the corresponding matrices. We have matrix 5y, 45, equals matrix negative 8, 12, plus matrix 15, 3x. Alright, now we compare the elements one by one. So the first element is 5y equals to negative 8 plus 15. So 5y equals to 7, hence y equals 7 over 5. So the next element, 45 equals 12 plus 3x. So 3x equals 33, hence x equals 11. Example 3. Given that matrix A is 5, 1, 7, negative 3, matrix B equals -5, -9. Matrix C equals -2, 4. Find A. Matrix A times with matrix B. B. Matrix B times with matrix C. C. Matrix A square. And D. Matrix A cube. So here's the solution. For A, matrix A times matrix B, so it is equals to matrix 5, 1, 7, -3 times with -5, -9. So now let's check whether these two matrices can be multiplied together. So the order for the first matrix is 2 times 2, and the order for the second matrix is 2 times 1. So these two numbers are the same, hence we can multiply these two matrices together. So visually group the first matrix horizontally and visually group the elements in the second matrix vertically. Then to multiply these two matrices together, so the first element will be 5 times -5 plus 1 times -9. Then the second element will be 7 times -5 minus 3 times -9. So you calculate everything together, we have matrix -44, -8. So the order of the result is 2 times 1. So this same number from these two numbers. So we go to B, matrix B times matrix C, so which is matrix -5, -9 times with matrix -2, 4. So let's check whether we can multiply these two matrices together. The order for the first matrix is 2 times 1, and the order for the second matrix is 1 times 2. So these two numbers are equal. Hence, we can multiply these two matrices together. So visually group the elements for the first matrix horizontally and visually group the elements for the second matrix vertically. Alright, so now the result will be the first element is -5 times -2. The next element will be -5 times 4. We move on to the next row. The element will be -9 times -2. And the last element will be -9 times 4. So calculate everything together, we have matrix 10, -20, 18, -36. So the order for this result is 2 times 2, which come from these two numbers. Alright, now move on to C, matrix A square. So it is equals to matrix A times matrix A. So which is matrix 5, 1, 7, -3 times with matrix 5, 1, 7, -3. Alright, so first we will visually group the elements for the first matrix horizontally and visually group the elements in the second matrix vertically. Alright, the result will be the first element is 5 times 5 plus 1 times 7. So the next element will be 5 times 1 plus 1 times -3. Then move on to the next row. The element will be 7 times 5 minus 3 times 7. And the last element will be 7 times 1 minus 3 times -3. Then we calculate everything together. We'll have matrix 32, 2, 14, 16. D. Cube of matrix A. So it is equals to matrix A square times matrix A. So we already calculated matrix A square from part C, which is 32, 2, 14, and 16. Then multiply with matrix A, which is 5, 1, 7, -3. Alright, so now we can start to multiply them together. So first we visually group the elements in the first matrix horizontally and visually group the elements of the second matrix vertically. So it becomes, for the first element, it is 32 times 5 plus 2 times 7. The next element will be 32 times 1 plus 2 times -3. The second row, the element will be 14 times 5 plus 16 times 7. And the last element will be 14 times 1 plus 16 times -3. Then we calculate everything together. We'll have matrix of elements 174, 26, 182, and -34. Or cube of A, matrix A, we can also write as matrix A times square of matrix A. So let's substitute the corresponding matrices inside here, which is matrix 5, 1, 7, -3 times with matrix 32, 2, 14, 16. So will we get the same result for the first part? Let's try it out. Alright, so again, the first matrix, we visually group the elements horizontally, and for the second matrix, we visually group the elements vertically. And then we'll multiply one by one. We'll have matrix of the first element 5 times 32 plus 14. The next one is 5 times 2 plus 16. The second row 7 times 32 minus 3 times 14. And the last element is 7 times 2 minus 3 times 16. Alright, and we calculate everything together. We have 174, 26, 182, and -34. From here, we can see that square of matrix A times A is equal to matrix A times square of matrix A. Now let's look at example 4. A. Evaluate matrix 2, 4, 1, -3 minus half matrix 2, 4, 1, -3. B. Given that matrix 7, 1, 2, 6 minus matrix 2, -y, x, -4 equals square of matrix 2, 1, 1, 3. Find the values of x and y. Here's the solution. For A, we have to evaluate this expression, matrix 2, 4, 1, -3 minus half matrix 2, 4, 1, -3. So we will multiply the half into each element of the second matrix. Hence, the expression becomes matrix 2, 4, 1, -3 minus matrix 1, 2, half -3 over 2. So, since this operation of minus, then we can minus the corresponding elements. So it will be matrix 2 minus 1, 4 minus 2, 1 minus half, -3 minus bracket -3 over 2. Then we calculate everything together. We have 1, 2, half, -3 over 2. Next, question B. So given this equation, right, so what we can do is from the left hand side, we can minus the corresponding matrices together since it is an operation of minus. So we have matrix 7 minus 2, 1 minus -y, 2 minus x, and 6 minus -4. They equals to the right hand side, so it is a square of a matrix, so the matrix will multiply itself. So we have matrix 2, 1, 1, 3 times matrix 2, 1, 1, 3. Okay, so we simplify the left hand side. We have matrix 5, 1 plus y, 2 minus x, 10. Equals to the right hand side. We multiply these two matrices together. We have matrix 2 times 2 plus 1 times 1, 2 times 1 plus 1 times 3, 1 times 2 plus 3 times 1, and 1 times 1 plus 3 times 3. So calculate the right hand side. We have matrix 5, 5, 5, 10. Alright, I want to find the values of x and y. So I will look at this element. So 2 minus x equals 5. We solve this equation. We have x equals -3. To solve for y, we will compare this element. So 1 plus y equals 5. Y will be equals 4. So this is the answer. Example 5. Given that matrix P equals matrix 7, negative 8, 2, 5, and matrix P times matrix Q equals matrix negative 10, 19. A. State the order of Q. B. Hence, find the matrix Q. So here's the solution. For A, to find the order of matrix Q, first let's see the order of matrix P. It is 2 times 2. And the order of matrix P times matrix Q is 2 times 1. So to find the order of matrix Q, we will look at this number 2 here, which means the number of rows of matrix Q is 2, and this number, which tells us the number of columns of matrix Q is 1. Hence, the order of matrix Q is 2 times 1. For B, so we know that matrix Q order is 2 times 1, so let matrix Q equals matrix AB. So matrix P times matrix Q equals matrix negative 10, 19. So we substitute P to be matrix 7, negative 8, 2, 5, and matrix Q as matrix AB. Alright, then we can multiply these two matrices together. We have matrix 7A minus 8B, 2A plus B, then equals to matrix negative 10, 19. So now we can compare elements by element. So the first element 7A minus 8B equals negative 10. Then we make A the subject. So A equals 8B minus 10 over 7. So we can label this as equation number 1. Next, we compare the second element, which is 2A plus 5B equals 19. We label this as second equation. So I will substitute equation number 1 into equation number 2, which will get 2 times 8b minus 10 over 7 plus 5b equals 19. Alright, now we multiply by 7 for both sides. We have 2 times 8b minus 10 plus 35b equals 133. Expand the bracket, we have 16b minus 20 plus 35b equals 133. So 51b equals 153, hence b equals 3. Now I want to calculate a. It will be equals 8 times 2 minus 10 over 7, hence the value of a equals 2. So matrix Q equals matrix 2, 3. Now we go to the last part of this lesson, which is application of matrices in problem solving. This is a very important topic because almost every year this type of question comes up in the exam, and usually it comes in paper 2. So here are a few tips in answering application of matrices question. Number 1. Read the questions carefully. Try to understand what the story is about. Tip number 2. Identify what information is given. Here is an example. Given number of items sold in a period of time from 2 locations. So usually a big table is given to summarize, which look like this. So as you can see from here, we have product A, product B, product C, and shop 1, shop 2. Alright, so which means shop 1 sells 10 units of product A, 15 units of product B, and 24 units for product C. So similar for shop 2, it have sold 20 units for product A, 12 units for product B, 19 units for product C. Okay, so if given this table, then you form a matrix from this table. So let's label it as matrix A, which is matrix 10, 15, 24, 20, 12, 19. And the prices of the products are given. So let's say product A, it is $2.50, product B is $3.50, product C is $5. So we can form a matrix from this information. So we can form matrix B as 2.5, 3.5, 5. Tip number 3. Multiply the two matrices together. So matrix A times matrix B equals matrix 10, 15, 24, 20, 12, and 19 multiply with matrix 2.5, 3.5, and 5. So when we multiply these two matrices together, we'll have matrix 10 times 2.5 plus 15 times 3.5 plus 24 times 5. And the next row will be 20 times 2.5 plus 12 times 3.5 plus 19 times 5. Then we calculate everything together. We have matrix 197.5 and 187. So the next question will be, what does matrix A times matrix B represent? Alright, the answer is matrix A multiplied with matrix B represents the total sales made by shop 1 and shop 2 of product A, product B, and product C respectively. Alright, which means the total sales for shop 1 will be $187.50 and the total sales made by shop 2 is $187. Okay, so the next tip number 4, sometimes you have to multiply matrix 1, 1 with AB. Alright, so this is how it looks like. We multiply matrix 1, 1 with AB. So it will be matrix 1, 1 times with matrix 197.5, 187. Okay, when you multiply these two matrices together, you actually add these two numbers together. 197.5 plus 187, which is 384.5. Alright, the question will be, what is this matrix about? Okay, so this matrix shows the total sales made by both shop A and shop B on that particular day altogether. Alright, remember we are adding these two numbers, which is the total sales for each shop. And there's the value, which is $384.50. Okay, do take note that when we multiply a row matrix with all elements as 1 with another matrix, we'll add the elements in the second matrix vertically, like what happened here. Tip number 5. What if we multiply matrix A with matrix 1, 1, 1? Alright, so this is a vertical matrix with all elements of 1. So this is how it looks like. Matrix A multiplied with matrix 1, 1, 1. So it will be matrix 10, 15, 24, 20, 12, 19 multiplied with matrix 1, 1, 1. Alright, so let's check. The order for this matrix is 2 times 3 and the order for the second matrix is 3 times 1. So we have the same number 3, 3. Alright, then we will group these elements and multiply with this element, right? Which we get 10 times 1 plus 15 times 20 times 1 plus 24 times 1. Similarly, these elements will multiply with these elements. We will have 20 times 1 plus 12 times 1 plus 19 times 1. And add everything together, we have matrix 49, 51. So take note that when a matrix is multiplied by a column matrix with all elements as 1, we'll add the elements in the first matrix horizontally. After understanding the concepts behind application of matrices in problem solving, now let's look at exam-based example 6. During weekdays, a restaurant serves set lunches and set dinners. two variations of lunches and dinners are served. The number of meals sold from Monday to Wednesday for each type of meal is as shown in the table. So here is the table. The prices of the set lunches and set dinners are as follows. So here are the prices for set lunches and set dinners. Here is the question. A. Write down a 3 times 4 matrix N that represents the set meals sold from Monday to Wednesday. B. Write down a 4 times 1 matrix P that represents the prices of set meals. C. Evaluate matrix N times matrix P. D. Explain what do the numbers in matrix N times matrix P represent. E. Calculate the total earnings from the set lunches sold for the 3 days. Here is the solution. For A, write down a 3 times 4 matrix N that represents the set meals sold from Monday to Wednesday. So all we need to do is just write down matrix N of 3 times 4 by copying whatever values that we have from this table. Alright, so 55, 54, 60, 65, 58, 66 and so on, all the way to the last element 65. As you notice, we don't change any position of the elements. Alright, so for B, write down a matrix, a 4 times 1 matrix P that represents the prices for the set meals. Okay, so we will follow whatever price is given here. So matrix P will be 13.7, 15.6, 19.9, 20.5. Alright, so this is a vertical matrix without changing any positions of the prices here. C. Evaluate matrix N times P. So let's multiply these two matrices together. So this is the matrix N. This is matrix P. Alright, so the order for this matrix is 3 times 4. The order for this matrix is 4 times 1. So these two numbers are the same, so we can multiply them together. So these elements multiply with these elements will have 55 times 30.7 plus 54 times 15.6 plus 60 times 90.9 plus 65 times 20.5. The next one, these elements multiply with this element will have 58 times 13.7 plus 66 times 50.6 plus 67 times 19.9 plus 70 times 20.5. Next one, these elements multiply with this element again. So this is what we get, 52 times 13.7 plus 60 times 15.6 plus 74 times 19.9 plus 65 times 20.5. Then we calculate everything here and we'll have 4,122.4, 4,592.5 and 4,453.5. Okay, D. Explain what do the numbers in matrix N times matrix P represent. So this is the result we get from part C. The first figure is the total sales on Monday. Second figure is the sales on Tuesday. And the last figure is for Wednesday. So this matrix represents the total sales of Monday, Tuesday, and Wednesday are $4,122.40, $4,592.50, and $4,453.50 respectively. Question E. Calculate the total earnings from the set lunches sold for the 3 days. So over here, only for the set lunches. Hence, the total earnings will be the number of set lunches multiplied with the prices. Okay, so the number of set lunches will be 55, 54, 58, 66, 52, and 60. Then multiply by the prices, which is $13.70, $15.60. Okay, now let's check. The order for this matrix is 3 times 4, and order for this matrix is 4 times 1. Alright, so we can multiply these two matrices together. But this is not the answer to find the total earnings, because we should sum the elements of the products for these matrices. Hence, it has to multiply this matrix 1, 1, 1. Okay, so let's check the order for this matrix, which is 1 times 3. And this number equals to this number, so we can multiply them together. Okay, so now let's multiply. It is equals to matrix 1, 1, 1 times with, so multiply these two matrices together. So these elements multiply with these elements, we have 55 times 13.7 plus 54 times 15.6. Next, these elements multiply with these elements again. So we have 58 times 13.7 plus 66 times 15.6. The next row, these elements multiply with these elements again. Alright, we'll have 52 times 13.7 plus 60 times 15.6. Now we calculate everything here. We'll have 1595.9, 1824.2, 1648.4. And in front, we multiply this matrix 1, 1, 1, which means we'll add all the elements here together. So which is 1595.9 plus 1824.2 plus 1648.4, and the answer is $5,068.50. So the total earnings for from the set lunches sold for the 3 days will be these values. Now let's look at one more example. Example 7. A company delivers sandwiches to 3 different schools. Table 1 shows the number of sandwiches supplied per delivery to each school, the choice of sandwiches, and sale price of the sandwiches. So here is table 1. As you can see, as described, this table shows the number of sandwiches supplied per delivery. So these are the numbers. The choice of sandwiches, so we have 3 choices: chicken, egg, and tuna. And the sales price per sandwiches. So these are the prices for the sandwiches. Okay, next one. Table 2 shows the number of deliveries made to each school over 2-week period. So this is the table number 2. So the number of deliveries over 2-week period for school P is 14, school Q is 10, school R is 11. Okay, as you can see from the first table, we can form one matrix for the number of sandwiches per delivery, another matrix for the sale price per sandwiches, and one more matrix for the number of deliveries over 2-week period. Given that matrix A equals matrix 550, 400, 600, 0, 100, 150, 200, 0, and 180, and B 14, 10, 11. A. Calculate matrix B times A. And B. Describe what is represented by the elements in matrix B times A. So here is a solution. For A, matrix B times A, so it is equals to matrix 14, 10, 11, multiply with this big matrix, 550, 400, 600, and so on. Okay, now let's check the order for the first matrix. It is 1 times 3, and the order for the second matrix is 3 times 3. Okay, so as you can see, these two numbers are the same, then they can multiply together. So it is equals to, now these elements multiply with these elements. We have 14 times 450 plus 10 times 0 plus 11 times 200. Next, these elements multiply with these elements, we have 14 times 400 plus 10 times 100 plus 11 times 0. Next one, these elements multiply with this element, and we will have 14 times 600 plus 10 times 150 plus 11 times 180. Okay, then we calculate everything together. We have 9,900, 6,600, and 11,880. So to B, what does this element, the elements of this matrix represent? So it represents a total of 9,900 chicken, 6,600 eggs, and 11,880 tuna sandwiches were delivered to the 3 schools over a 2-week period. Question C. If matrix C is such that the elements in AC represents the total number of sandwiches delivered to each of the location per delivery, write down matrix C. D. Calculate A times C. So here's the solution for C. So since we want to calculate the total number of sandwiches delivered to each location per delivery, so we have to add all the elements together. Hence, matrix C will be a vertical matrix of all the elements are ones. Okay, so the D, what will happen if matrix A times matrix C? So this is what it looks like. This is matrix A times matrix C. So the order for this matrix is 3 times 3. The order for this matrix is 3 times 1. Okay, so now to multiply these two matrices together, so this element multiplied with this element, we'll have 550 times 1 plus 400 times 1 plus 600 times 1. Then move on to the next row. These elements multiply with these elements. So we have 0 times 1 plus 100 times 1 plus 150 times 1. Then these elements multiply with these elements. We have 200 plus 1 plus times 1 plus 0 plus 180 times 1. Okay, we calculate everything together. We have 1,550, 250, and 380. Question E. Using matrix multiplication, calculate the total amount of money that will be obtained from the sale of all the sandwiches to the 3 schools per delivery. Alright, so here's a solution for E. Now let D to be the prices for the each types of sandwiches. So it's 3, 2.5, and 3.5. Hence the total will be A times D. Alright, so this is matrix A, which is the number of sandwiches delivered per delivery, multiplied with the price of each sandwiches. So the order for the first matrix is 3 times 3, and the order of the second matrix is 3 times 1. So these two numbers are the same. Okay, 3 and 3, then we can multiply these two matrices together. Alright, so these elements multiply with these elements, we will have 550 times 3 plus 400 times 2.5 plus 600 times 3.5. Then these elements times these elements, we have 0 times 3 plus 100 times 2.5 plus 150 times 3.5. The next one, these elements multiply with these elements, we'll have 200 times 3 plus 0 plus 180 times 3.5. Calculate everything together, we'll have 4,750, 775, and 1,230. So we want to find the total amount of money. Then this matrix, we have to multiply with this matrix, where this matrix comes first, followed by this matrix, so that we can add all these numbers together, which will have 4,750 times 1 plus 775 times 1 plus 1,230 times 1. Alright, add everything together, we have 6,755. Hence, the total amount of money obtained is $6,755. Alright, that's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, see you in the next video. Have a great day ahead and all the best.